Name's Mary English, and I am here to give a presentation for you as a resource on how to approach retrofitting your building to be more energy efficient. And so this is just going to talk a little bit about all things building performance and along with um, the science. We're going to talk about commonly seen energy issues in our region, in the Kansas City region, best practices for making those upgrades, and then there's some resources I can share with you. So without further ado, let's start with the introductions. I am with Metropolitan Energy Center, and we are a 42-year-old non-for-profit that has been dedicated to reducing energy use in both the built environment and the transportation sectors. We have a demonstration home here in the Kansas City region, and then multiple projects for infrastructure implementation on the transportation side. Resources information on building performance on our website. Please reach out if you have any questions. So you know that I'm not just somebody here for fun. I've been in the industry and I could talk about this ad nauseum. Don't worry, this is only about a 40-minute presentation, but I can give it because I've been in this industry for roughly 17 years. 12 of those were spent as a residential energy efficiency specialist and 5 of those in commercial. I've personally, through my own business ownership and implementation, I've conducted hundreds of home energy audits with some commercial audits thrown in. And I've worked for many people in the industry, from your single family home builders to your larger multifamily home developers and commercial building contractors. And this builders in that space have made a commitment to build energy efficient buildings. And with that, you need some testing. So done vigorous testing on hundreds of buildings in this region, and have really learned a lot in the trenches. So that's about me. Let's go into a quick tutorial on why we need energy efficiency and how it works out there. So retrofits for efficiency in the built environment are commonly seen as something that folks, if they want to save on their utility bills, if they feel that maybe their building that could be more efficient, and they will see a payback in the bills, that is usually the reason folks do this. But an energy retrofit and an energy building really is addressing what we call this whole house or whole building system. And it impacts the durability of your building shell, otherwise known as the envelope. It impacts how well your heating and cooling systems work, the length that they will maintain their working life can be greatly impacted by improvements made to the envelope, for example. The delivery system, i.e. usually your ductwork. We still have some boiler heating in the region, but most buildings with the advent of air conditioning were retrofitted to have ductwork, and the ducts really need some work. Usually, almost all buildings, the ductwork is a problem. Your lighting is addressed through a retrofit. Most lighting these days is moving towards efficient lighting packages, like fluorescent at bare minimum, but LEDs have come along and are extremely efficient and should be talked about. And then also retrofits can take a look at how well your foundation is draining, the relative humidity, how much moisture is inside your building can really impact your indoor air quality in the structure. Did you know that on average, this is a statistic that our partner Children's Mercy Hospital talks about regularly, 9 out of 10 breaths we breathe on average are breathed indoors. And so the energy efficient upgrade is really primarily focused on making sure our indoor air environment is clean and healthy. I alluded to the whole building approach earlier. Now I want to talk about it with some examples. Again, it's the building is a system. You can treat it as an analogy to the body. You go outside without a jacket in the winter, you're going to feel cold right away. And that means that the interior of your body, it kicks in to start burning calories to keep your body temperature at the same level of 98 degrees. Well, systems have varying components in your building that impact one another. So, for example, more insulation and air sealing in your building envelope mean that your heating and cooling equipment can be smaller. And that means you get to save money, especially if you're doing a gut rehab or a brand new building. You want to make sure that the building envelope is insulated as tight as possible, and then your heating equipment can really be a very small, affordable system up front. Duct sealing means that your heat pump technology and HVAC can be used more effectively. This is especially true as many building managers are switching over to electric heating via heat pump. Those heat pumps operate in a different way than gas-powered heating equipment, and they really need an effective delivery system, i.e., a very tight duct trunk line and ductwork all need to be well sealed in order for that heat pump to work effectively. An updated HVAC system means that maybe you can then add a building moderating system that can regulate that system without much labor involved. That will help you save in maintenance costs and, of course, utility savings, and then again add to the benefit of comfort and health for humans. Let's talk a little bit about the envelope. Again, it doesn't necessarily mean the entire walls, floors, and ceilings around a building. It means the barrier between an unconditioned space and the conditioned portion of the building that you are paying good money to heat and cool in the summer and winter. So this illustration here is showing, for example, that barrier between the non-conditioned attic space and the conditioned envelope, or excuse me, the conditioned space is indeed the envelope. So you wouldn't call that A-frame roof line the envelope. We're calling that border between the unconditioned attic and the top floors the envelope. I want to go over how our buildings interact through the laws of thermodynamics. So this may be very elementary to you, the listener here, but we have to talk about it because that's how we understand building science, that heat/energy move from high to low. So hot is always going to be moving to the coldest spot and interchangeable with that high energy heat for the sake of this presentation. So for example, this illustration, the square dumbbell, if it was sitting in a vacuum, that hot temperature would move quickly over to the cold side until that whole dumbbell was the same exact temperature throughout it. And then it would stop moving because it's all the same temperature. Heat and energy are always trying to equalize by moving to the cold or low energy direction. And that speed depends on the temperature difference between the high energy and the low energy and the material that it's passing through. And there are three ways energy/heat interact with our built environment. The first one is most well understood is conduction. And by saying most understood, I mean by the layperson, who I once was. This basically illustration is showing you hypothetical indoor, outdoor on either side of an unconditioned brick wall. That is a very conductive material, and so the temperature difference would being steep between a very cold day and a heated indoors is also going to be a big gap. And so that means that the energy is going to move quickly. The bigger the gap in temperature, the faster the heat moves. An illustration here on the lower left is showing that, like a metal rod, metal is very conductive. Those of us that cook with cast iron pans on the stove know this. The handle's going to get very hot, even though it's not sitting directly over the flame. It's the same with conduction. It's energy conducting through material, and insulation added to that wall is what slows down that conduction. Second way heat transfers to a building is solar radiation. Radiation is best known here on a micro level as perhaps sitting around a campfire roasting marshmallows. The heat from the fire is radiating towards you. If you had a screen in front of you that completely blocked it, you wouldn't feel that direct radiation. Our buildings absorb our solar radiation through our windows, through our walls, and it needs to be understood and mitigated by the materials that we use in those windows and those walls to either use it, which you can use the solar radiation in a building called passive house. This presentation isn't going to go into that detail, but just know that it's not necessarily such a bad thing when you get solar radiation, depending on the construct of your building. But it is something usually that energy efficiency is trying to mitigate that heat gain through the windows. The third law of thermodynamics is movement via convection. That is movement in air. The example here, of course, is the hot air balloon, which is using hot air, which is lighter than cold air, and so it rises. The illustration on the right, not to confuse, based on what I've been talking about, the transfer of heat. If the wind is cold and blowing, it's going to move into your house, and then the heating equipment takes over. And then the way that heat moves is through the laws of convection, and your professional heating and cooling contractor will know how to design a duct system and size the HVAC system to, based on the elements of your building, how well insulated it is, how leaky it is, to build a system that will be able to counter that cold air gain through the envelope on a cold winter day. I'm going to pause here just to say the point of all this really in the energy efficiency profession is to look at a building and figure out how to keep it dry, keep it at a consistent temperature throughout, make sure the humidity levels are correct, not too high, not too low, make sure it's allergen free, and make the affordability just a no-brainer fringe benefit. The reason we recommend a lot of this is for comfort, durability, and occupancy health, and the affordability aspect turns into a really nice way to get your return on investment of doing this work. So let's talk about the commercial building and how to approach it. I'm going to talk a little bit about how the profession works and identifying how to upgrade your buildings first. So the best practice approach really is to hire a professional to start with what's called a level 1 assessment. That is basically just a rough walkthrough with an energy specialist using their own senses without any testing equipment or infrared analysis. Walk through, and trust me, an energy professional, it's well worth it, will be able to spot things that maybe you walk by every day, not realizing that are causing strain on your HVAC system or discomfort, what have you. An energy specialist will be there to give you a laundry list of recommendations after the walkthrough, which will be, again, based on this occupancy, health, and safety issue, the ease of implementation, and your return on investment, and then with sources to help pay for it, help pay for the work. This is what a good energy assessor will give you, this type of prescription. And then it'll be up to you, or to hire a general contractor to find the bids and do the work order and keep moving. You might have the next step in there that I didn't include in that sort of graphic as a level 2 energy audit. The level 1 energy audit, again, just known as the walkthrough, that's a basic assessment, and it also involves, besides the site visit and survey, a utility bill analysis and called benchmarking, which we'll get to in a minute. You'll be interviewing maybe occupants and facility management staff. And again, the goal is to identify the low cost and no cost energy saving opportunities and potential areas for further investigation that might be a level 2 audit recommendation, which then brings in the equipment. It maybe brings in an infrared camera and testing equipment, and it's a more thorough assessment of the building. So I'm going to focus on these attributes a little bit further. So we look at the air leaks as the number one opportunity to creating a more efficient facility. Think of the building as something that breathes. So besides, of course, the science of heat and energy, the basic heat and energy transfer through temperature differentials, we do deal with pressure differentials in buildings too. We have our heating and cooling equipment that is adding pressure or lack thereof. We have your other equipment in a building. Maybe you have a clothes dryer that is blowing out 200 cubic feet of air a minute while it's in dry mode. That is depressurizing your building. Don't mean to get too technical, but just know that if you have 1 cubic feet of air that is being absorbed through a cold wind into your house through the lower part of the building, that means that 1 cubic feet of air needs to escape. The building isn't going to blow up like a balloon with a cold air infiltration. It just pushes out the hot air out the top of your envelope. And this is why we need to get a handle on the air leaks, why it's a huge affordability issue. Leaky houses cost a lot of money to heat and cool. And it's a comfort issue. I mean, think about this. If you are in the house is inhaling in the lower part of the envelope, house or building, commercial building too, 22-degree winter air, that means it has to exhale out 1 cubic feet of 70-degree or whatever your thermostat is set to, air out the top of the envelope. That gets expensive, and it's also can be uncomfortable depending on where you are in the building. Another important focus on the energy walkthrough is checking for insulation levels in the envelope. So sometimes this is, depending on the construct of the building, is easier, depending on, what is in the walls. But this is an infrared image that was taken in the winter time. The ceiling above is completely uninsulated, and we know this because the coldest color, that purple, is a lower temperature than the ceiling joists, which you can see are warmer temperature. So that cold in between the ceiling joists means it's completely uninsulated. If it were insulated, it would be reversed. The ceiling joists you would see as colder than the cavities, but because the cavities are colder than the framing, those joists, it means that it's uninsulated. There's really no substitute for seeing into walls and ceilings than an infrared camera. If you suspect that your building is mostly uninsulated, it might be really worth it to get a level 2 assessment, or at least somebody just to come in and do an infrared scan. You have to do it when the temperature difference is at least 20 degrees between inside and outside. So infrared doesn't work very well in the moderate spring and falls in this area. I wanted to just again illustrate a little bit more about how insulation works. So insulation's effectiveness is classified as R value. So you'll see something that says R13 on the most commonly known piece of insulation, the fiberglass bat. It means that the total thermal value, resistance value is that 13. The higher the R value, the more effective it is at slowing the heat transfer down. Fiberglass, for example, is roughly 3.5 R value per inch. Well, we have other products like a high density foam product, which is an R7 roughly per inch. But different products should be used in different cases depending on the entire construct of the wall. So this illustration is really just showing again that without insulation at all, energy is escaping fast with that big red arrow. And then you add insulation in your wall. Now again, that rapid heat loss is mitigated, is slowed. Unless you're a rocket scientist, you're never going to completely stop heat transfer. The idea is really just to slow it down considerably so we don't feel the loss through comfort or feel the loss on our utility bills, right? One focus I want to make sure everybody just gets note on is that when we do have gas burning appliances in our buildings, it can mean that it's a very specific health issue that you need to be made aware of. Most energy auditors, energy assessors have gas sniffers and carbon monoxide detectors that they go into the equipment rooms and check all over for leaks and for unhealthy levels of carbon monoxide. It really does matter a lot. I saw many instances in the field, which actually there's a good picture of here in the next frame, of something like this, that if you don't know, what you're looking at may mean nothing. But what this is a two gas appliances. One is the furnace and air handler next to a gas burning open flue um, water heater, domestic water heater. And I can see right here in the picture that first of all, the water heater's flue is on a downward slope as it goes to join the furnace flue, which is a big no-no. But also it's right next to the return trunk line. And, you're heating your forced air system kind of like I was saying in the building, it's one in, one out. So your air is being pushed out through the supply. That means that it's sucking air back through the return. And if your return lines are unsealed, that means you have leaks that might be drawing in waste gas from that flue into the trunk line. That is an unhealthy setup right there that we're seeing in this picture. And it's something that energy assessors will make a note of in your report. All right. So let's talk about, instead of concepts, let's talk about specifics. I'm going to give you the low-hanging fruit of common retrofits that we recommend in this region. Here's the short list. It's not completely comprehensive. Again, there's all types of things that you can do to a building I'm not addressing here. The most common one being adding solar panels. I'm an energy conservation specialist. Solar panels should be added after all the conservation measures are done. For one, conservation means that you don't need to buy as many solar panels if you're using less information, or excuse me, energy. And secondly, our region may have varying degrees of needs for the building, and not every single one can be addressed here. Energy conservation is what you need for that important occupancy health. The generation, the solar panels are important, but I'm not focusing on them here. So this list that you're seeing in front of you is in order of generally what we see the best return on investment and ease of implementation. So air sealing, like I said, is number one. Adding more insulation is usually going to be second. And then the rest of these, again, going down from return on investment or ease of implementation expense. And I'm going to touch on each one here. So first, again, air leaks. So these are two images from a couple of walkthroughs I've done in the last year in commercial buildings. And may mean nothing to the average eye, but to an energy assessor, especially that top image there on the left. That is a huge hole in the ceiling bordering the attic next to the heating and cooling equipment trunk line. And so a huge amount of energy is being lost through that hole. And when I'm talking about adding an air barrier, I'm not talking about adding like a porous cloth. It needs to be something that is technically considered an air barrier. So I would be recommending for this person in on this picture on the left, a cut to fit foam board sealed around all penetrations with low cell spray foam to seal it in there. On the other picture, you see a much smaller hole that is next to a rubble foundation wall next to the ceiling joist of the conditioned space overhead. Somebody already tried to foam part of it, but missed a spot. And those, what you think might be a little spot, really add up to being a huge amount of air infiltration and then loss out the top of the building. So quickly foam caulk, depending on the size of the gap around the foundation and the top floor to attic connections and other penetrations. Something I don't have here pictured is the rim joist, which is the main floor joist that sits on top of your foundation wall. And we call that the rim joist. Those gaps where you most commonly see a lot of people stick fiberglass in there in their homes. Um, when you really need a foam product to really well air seal that rim joist and can cut down immensely on your air infiltration just by doing that one thing, is foaming and insulating your rim joist using the best practice using foam. But easier stuff, weather strip around your doors and windows when relevant. Make sure that your exterior doors have a threshold that seals up against the bottom of the door. So many people add weather strip and then forget the threshold. Block off any unused elevator shafts or other building height chases that can be blocked. I just was in doing an energy assessment a couple of weeks ago where there was an old elevator shaft that had lots of leaks. And so those shafts just act like a furnace fluid, just whoop in the winter, especially just the hot air just goes like a freight train out through that shaft. And then look for where else that you can seal around your penetrations. Crawl space foundations can be hugely inefficient, add to a lot of pain on utility bills and a lot of discomfort issues, but they depends on what is in that crawl space, if it's being used for ductwork, whatever the case is, you should talk to a professional about how to weatherize the crawl space correctly and what your options are there. If you do it incorrectly, you can introduce problems like mold where there wasn't there before. But it's a huge opportunity to add efficiency and comfort and health to your building by addressing any crawl spaces with a professional. Next focus is the ductwork. Again, I can't stress enough how important our delivery system is to not leak. Conditioned air should be considered as a fluid like water. So you don't want your water pipes to leak, it leads to damage, right? It's more well known what kind of damage you can get with a leaky water pipe than with a leaky duct. But ducts, as far as how they pass air, if they are very leaky, that means that the air to your rooms the farthest from the air handler from the heating and cooling system may be consistently cold in the winter and hot in the summer. That is because all that expensive air is leaking out on the way to those rooms. You really need to make sure any exposed ductwork that you can access easily gets retroactively sealed. You do that with what's called UL 181 foil tape, which is a really great product, but it is more expensive than what I have pictured here, which is water-based mastic, which is cheaper and can be painted on like a brush. Gets a little bit messy, but it's very worth it to access those ducts and air seal around every seam. You can see holes in this connection with the duct to the trunk line. All of those are leaking out copious amounts of air. There are products out there, there are businesses that do duct test and a product that seals on the interior of the ductwork. This is really good for ducts that are behind walls and in floors that you can't access due to drywall being in the way. And I would highly recommend looking that up and getting a professional consultation and test on what it would cost to air seal those. Start, if you suspect this is a problem, start with your staff or building occupants in the furthest reaches of the building away from the heating and cooling equipment. Start seeing what their comfort levels are like. And that way you can sort of investigate your own duct leakage problems. Okay, attic. So by attic, I mean an attic that is this unconditioned space sitting over your top conditioned floor. Um, Many commercial buildings don't really have an attic. It's just a flat tar down roof assembly that may just be completely, um, what the insulation is what it's going to be, and there's no way to retroactively insulate that. But if you live in a building with accessible attic space, pay close attention because this can be a huge return on investment and a huge comfort booster in your building. The goal of the flat attic space should be 16 inches of loose blown insulation. Never use a rolled out bat. It's not a best practice. It doesn't insulate a attic well. To start, you're going to want to foam around any penetrations. Caulk foam, depending on how large the hole is. Obviously, you don't want to be using any product up against a hot furnace flue, but other than that, you can go pretty nuts now on the market. Making sure any recessed can lining is well air sealed around. Assuming those cans are using LED lights, incandescent lights are too hot. And then, once you insulate, or excuse me, you air seal around those penetrations, then you can blow that loose blown insulation. I did want to show you not a best practice, the opposite of the best practice here in the lower left hand corner of this presentation is a fiberglass bat that has been installed incorrectly. The craft paper should be facing down, but regardless, bats just don't fill those crevices and really filter down and really provide that nice insulated cap. You don't want to use that. And make sure that your accesses are weather stripped. I do also want to talk a little bit about what we call knee walls in the energy efficiency business, which are the vertical wall that separates an uninsulated attic space from an insulated room. That would be considered part of the envelope, and you want to treat that knee wall almost as much as you treat an exterior wall. You want to make sure that it has a well-sealed air barrier. So you don't want to just hang fiberglass bats on that wall and leave it alone. You need to make sure it's enclosed, sealed, and completely constructively staying there with that air barrier, and make sure that the floor joists below that knee wall are also air blocked. Again, with foam board cut to fit and spray foamed around as a best practice. Next focus, HVAC retro commissioning. So retro commissioning is basically another word for an audit on your existing HVAC system and the delivery system, anything that's connected to it. A professional, it's a fee for service professional, will come in and do this complete assessment, this complete audit, looking at everything down to a loose nut and bolt, for example. This is a really unsung, underrated action that commercial building owners can use to save a ton on their utility bills and also really benefit the building occupants for their health and comfort. And it has a very traditionally fast return on investment. Since this is an underused resource in our region, we don't have a ton of case study on it, but I do have anecdotes. I have one professional that gave a presentation that said he found over a third of the fan boxes in this VAV fan system that he was doing a retro commission on not operating as designed. The fans weren't working. And had that commission not been done, just would have been an uncomfortable, expensive to run office because they wouldn't have had that information. Retro commissions not just save money on your utility bills once the upgrades have happened after the commissioning is done and the upgrades are then installed. You can expect the maintenance on your equipment to also cost less. One of the board members at Metropolitan Energy Center used to work in the telecommunications industry, and they built 175 brand new LEED certified retail outlet stores, and that process required a commission after the install of the HVAC equipment, and they realized $1,500 a year savings per each retail outlet in maintenance costs alone. So that adds up. And, again, if anything related to the HVAC system is going to be related to comfort and health. And so it's highly recommended that this get done in your building if it hasn't been done before, and you will reap the rewards, the return on investment and the comfort and durability rewards. While we're here on HVAC equipment, there's certainly instances where you just will need to replace the whole thing. Forget the retro commissioning, just go in and replace it. This is really good for equipment that is 20 years or older, of course. The older equipment, the more you're going to want to replace it. But you want to make sure you do it the right way. Do any envelope improvements first. Air sealing, insulation, installing storm windows. That way you'll be replacing a system that is perhaps smaller, cheaper to buy and cheaper to operate. And it'll be sized correctly based on the added insulation and air sealing and other energy efficiency attributes you added to your building. If the equipment is fairly new, if it's under 20 years old, a commercial system, and it's been well maintained, you might want to just, again, consider that retro commission first before you go willy-nilly and just replace the equipment. See if it can just be improved and updated with just a few tweaks here and there. And then certain types of commercial equipment can be retrofitted, much like you retrofit your lighting from incandescent or fluorescent to LED, which is a huge return on investment. If you have old lighting, I'm not addressing it in the slide here because it's pretty much well known that the types of lighting available, call a professional. But on the HVAC side, less well known is the fact that we have old motors. Outdated technology motors are still being installed in brand new equipment. We have a lot better technology that manufacturers just aren't using, just due to what they want to spend money on, called the electrocommutated motor. And I worked for a company that RTUs could be retrofitted with a variable frequency drive and this electrocommutated motor, and they would see their return on investment in less than 2 years, sometimes even a year, with these improvements on their rooftop units. So again, talk to your facility manager or talk to a professional and see what might be able to be done rather than a complete HVAC equipment replacement. But if you do go for a complete equipment replacement, again, make sure your envelope and your ductwork is addressed before you pick your equipment. Building management systems, a great way to save time and your own personal energy, no pun intended. Well, maybe it was intended, but BMS systems, with the advent of artificial intelligence, AI, and sensor data, you can now get a system that basically just is mostly hands-free. The facility managers are there to act when a sensor goes off and gives a warning that there's a problem with the system. So it saves on maintenance costs, it saves on heating and cooling costs, and also not just the HVAC equipment, but it can also be installed to control lighting and other electronics, without very much attention from human hands and minds. Watershed management. This should be an important focus if you haven't already. A lot of times, obvious problems with major flooding in a basement are addressed in our part of the world, but seepage and less water leakage in the foundation may be ignored because it's not seen as that big a deal. Well, high levels of relative humidity are a problem in our buildings because of water infiltration. And high levels of relative humidity can lead to mold growth in unseen places like your walls and drop soffits, and again, lead to poor indoor air quality, which is so important for us to maintain for our health and joy as building occupants. Last, not least, definitely not on expense, are windows. Replacing a complete window is mostly a slow return on investment because windows, as far as the cost per square foot, are the most expensive to implement. Windows are just expensive, and so many people don't go about it the right way. They just think the window assembly itself, perhaps you have an old single pane window and you just replace it with a double pane window and you think you're good. Well, no, if this construct has what we call a rough opening, which is usually what your window trim hides, um, the best practice is have somebody come in, remove the trim if it's easily be removable. Some aren't, and do what we call foaming around the rough opening, which is pictured here on the left. It's a waste of money to replace your windows without making sure that the rough opening and the assembly is well air sealed as well. Um, Also, in many cases, a storm window can be added at a third of the cost of a complete window replacement. This can be especially true. I know some historic renovations have allowed not maybe the window being replaced, but a storm window being added. And I mean, historic or not, storm windows are just a really good idea. As a step before any windows are replaced. Of course, if the window is broken, replace it, but realize that you have options. Um, as far as blocking that solar radiation, of course, more efficient windows do provide more protection from direct solar radiation, but window shades or awnings, especially on your south or west side of the building, can do that work for you. And provide a lot of good shading in the summer while also allowing some radiation to get in the winter because the sun's lower in the sky. So look into that if you have rooms that get too much solar gain and are too hot. Wall insulation is a tricky retrofit. I'm not going to not going to lie, but it can be a very great return on investment if it's needed and done right. And by needed, I mean that we have a lot of buildings with walls that are completely uninsulated and they make up the largest portion of your envelope, right? Your ceiling and your floor. But then if you have a four-story building, all this wall space, if it's uninsulated, that is a huge money pit. However, the retrofit of a wall needs to be done right. Um, Depending on the wall construct, if you have completely uninsulated walls behind lath and plaster, you can do a drill and fill. Again, a professional, there is a right way to do this, and you'll want to talk to a professional that is experienced in the retrofit wall insulation. You can, if you have interior masonry walls, you can apply high density, the hard shell foam on a masonry wall correctly, but again, you need to talk to an expert first, especially if you have a lot of, it's a foundation wall, you have a lot of water infiltration. You want to make sure that you talk to a building scientist to do it correctly. You can also use what we call low density foam product also to retrofit your above grade walls. But if it's not done right, it expands too much and can damage the framing. Talk to a professional. But if you suspect that all your walls are uninsulated, this should be something to eventually explore if you're going to be in that building for at least 7 years. Okay, so we're in the home stretch here. I'm just going to talk about some things to help you get started if you haven't already. For your own information, if you want to just kind of explore this without calling a professional first, or leaving this to an experienced facilities manager, go to the EPA and DOE websites and find your type of building treasure hunt map and checklist. They also, on these websites, in addition, have case studies and how-to guides, but these checklists are categorized by building type, and you can go in and find the one that most reflects yours. So, for example, a supermarket and grocery store's checklist is going to look completely different than an office checklist, because the former has a lot of refrigeration, and that's not going to be included in many of these other checklists. Each checklist, again, is customized to the building type. This example is just 2 sections in the office checklist. They do have checklists for HVAC and your ductwork and thermostats and all these other things. They are very comprehensive and can be fun to sort of go through. If you have a sustainability committee amongst your staff, this would be a really great way for that sustainable committee to sort of use their time, is to play around with these maps and checklists and see what they can maybe do just on their own with the low-hanging fruit. One tool that I haven't talked about much, at the same time you're looking at these checklists, it might be a good time, if you haven't already, to get a benchmark of your building space. Benchmarking is basically just a base level of what your existing building is using for energy right now. The most common tool used for this is called Energy Star Portfolio Manager. It's used throughout the country in most of the benchmarking programs run by our public economy. So, for example, Kansas City, Missouri has a benchmarking ordinance of 50,000 square feet or more of your building, commercial building. You have to submit your utility bills into their benchmark database, and it allows you to see how much energy your building is using in comparison to other like buildings. It allows you to get a baseline for what you do need to improve if you don't know where to start. And of course, once you make those improvements, you'll save money on your utility bills over time. The Kansas City, Missouri, again, this is just KCMO alone, but you can benchmark anywhere. You can go in and create a free account on Energy Star Portfolio Manager and benchmark your own building. For Kansas City, Missouri building owners, though, the top few links are really good use of your time. The top one is showing you how and why and where to link into their system to benchmark. If you have an address here in Kansas City, chances are you already have a benchmarking number assigned to you, and you can just go in with their lookup tool with your address and get that number, and then you can feed that in through their benchmarking link into their portfolio account and have your building registered, as long as you enter your utility bills for their information and for yours. And then there's some other training resources. If you operate a small campus, or if you just want to go through their series of how to use Portfolio Manager, and they have a lot of advanced tools. There's the bottom link there to look up their training videos on YouTube. Finally, we do have some really great utility rebate programs in our region through Evergy, Spire, Ameren, and other regional utilities. Basically, depends on where you are, what that utility looks like. So you're going to want to reach out to your representative. Evergy, for example, here on their brochure have several, depending on where you are. But both states, both sides of the state line do have utility rebates available, and they can be what's called prescriptive, which is what this is. This is a just a clipping out of the Evergy prescriptive rebate brochure, which basically just find what you need, make sure that you're buying exactly what is specified from existing to your upgrade, and the efficient in the middle column there. And as long as those two are listed correctly on what you have in your building and what you replace it with, then you can just take the receipt and claim your rebate through that prescriptive program. Lots and lots. I mean, I'm just showing you here one portion of one page, everything from HVAC to refrigeration equipment, lighting, all these things will have some type of rebate affiliated with them if it saves energy. Utilities like these programs because it helps with their demand charges. The custom rebates for utility are also available. This is a example of the custom rebate project for Spire. So custom works a little bit different than the prescriptive. You basically you have to get a walkthrough of some sort from a third-party energy professional. So it has to be somebody doesn't work for the company, your account. And then they will do a full, maybe even energy model on what you have versus what you want to replace it with, and prove that you save a certain percentage of energy. And then the rebate, you can see here, this is Spire, so this is gas, is classified MCF. So the rebate on these case studies here shows $6 and change per MCF saved, and their rebate was over $22,000 for the project here on the top as this example. You can get some good money for your rebates. I past life did some rebates in the refrigeration world, and we saw six-figure rebates a few years ago through a rebate program to replace refrigeration equipment, for example. Well, that is it. Thank you for coming to my TED Talk. I am going to not put my contact information, however, on this last slide. If you need more information, please contact Marlene Nagel at MARC, the Mid-America Regional Council. She is in charge of this RAMP, Renewed Non-for-Profit program, and can help you find your way further. Thank you so much. I hope you've enjoyed this talk, and I hope to see you out there in the universe. Take care.